Okay. Good morning, everyone, and welcome to Scalable Modular iOS Architecture at Just Eat. My name is Alberto, and today I'm going to talk to you about the journey we took to modularize our consumer apps at Just Eat. Under normal circumstances, I would ask how many of you in the audience are currently working on a modular code base. Unfortunately, we cannot do a show of hands today, but let me tell you that the last time I did it, roughly 60% of you raised their hand, which is definitely a good number. More and more people discuss this topic over the past few years, and pretty much at every conference I went to, there was a talk about modularization and building apps at scale. I think it makes a lot of sense because all software that grows beyond a certain level of complexity has to eventually be modularized, broken down into smaller parts and more manageable parts. And all the reasonably large organizations seem to have bumped into this problem after many years of mobile being a thing. Surely we do not live in the same world when the first mobile apps started appearing 12 years ago. So today I'll tell you a story, our journey to this path, the relevant history that brought us to having a modular architecture that can actually scale, the challenges we had faced, and I'll give you some advice that we came to learn during the years, giving you a bird's eye view without bugging you too much on the code. So let's jump right in. I cannot tell you about the journey if I don't introduce the company real quick. For those of you who are not familiar with the brand, Just Eat Takeaway is the merge group created in 2020 from the merger of Just Eat and Takeaway.com. We now operate in 24 countries, and depending from the country you're watching from, you might recognize the original Just Eat logo on the red background. As a consequence of the merger, we rebranded all the countries to the stunning orange of Takeaway.com, and we inherited the house logo as well. It's fair to say that what you will hear today comes from the side of the original Just Eat tech department. So it all started in 2014. At that time, apparently, the complexity of the whole platform raised so much that engineers were not able to deploy pretty much any platform change for a few weeks straight. This should trouble you a lot if you are a CTO. And in fact, the CTO at that time made the bold decision of internally split the company to move faster, or at least split the tech department. So you know the button at the top right corner of GitHub, the one that reads fork. Well, the engineers did press it for every single component. So separate teams were created. Those based in London, the office I was and still am based, would take care of the UK app and services, while others in Bristol, where our second biggest office is, would take care of the rest of the countries Just Eat operated in. There were 10 in total from Italy, Spain, but also later Australia and New Zealand. So there were two platforms at play, UK and international. The UK was the biggest growing market, far more prominent compared to continental Europe, and it needed dedicated attention to keep the growth going. This created a very hard separation. Teams were not talking to each other, were pretty much isolated, and during that time, things did only diverge more and more, with independent teams introducing new features only in one country without an overall control. Until something happened. In 2016, a new CTO called me and other people to his office and said, Alberto, we cannot continue to have different teams doing very similar things. We have to merge the platforms and the apps into a single global stack. And just to give us a bit of pressure, he also added, I want this to happen in 9 months. The vision was clear: put a stop to the increasing fragmentation, globalize the platform, and of course, obtain a more simplified stack. He also stressed that the benefits of having a single team is reducing cost and have a small and agile group able to introduce changes more quickly. So like any other team at Just Eat, I started making a plan for iOS that, as you will see shortly, deeply involved modularizing the code. As you can see from the slide, it took a bit more than 9 months to modularize the apps and get to a single code base. And that's because along the way, we also kept the product evolving, of course. Some teams in other companies modularize their code base because it's simply how it should be, modular. It's easier to maintain, enforces the separation of concerns. It allows to introduce changes more quickly and with a clearer impact area. While this is all very much correct and valid, our root motivation instead was to solve a business problem. So that's about the relevant historical facts. Let's talk about the challenges we had to face. After a memorable tech announcement about merging the two sites, UK and international, we started having the London and Bristol teams working together. This is when we learned that it's important to integrate people first and technology later. People were quite territorial at that time, which is understandable. Everyone was keen to push forward their own solution, the one that they've been working on for the past few years. With me in London pushing for UK to be the app of the future, and other engineers in Bristol pushing for their app to be the winning horse. After some months of discussions on the way forward, we eventually agreed that the right path was to build a cluster of modules that both apps would gradually onboard to share more and more code and features, and ultimately make the two products quite similar with the same set of features, or at least have the ability to feature flag them on and off on a per country basis. So this is us in 2018, and more recently in 2020, we're counting now more than 20 iOS engineers in the original Just Eat side of the merged group. So getting people to work together on a shared roadmap was key. Engineers who don't buy into a long-term plan would not be motivated and therefore would not move any project forward. Even worse, with remote teams in a pre-COVID world, if you're not co-located, it's harder to do anything, to share ideas and to create a unified community. So managers decided to organize constant face-to-face meetings to create a solid group able to be effective towards a common goal. We started traveling regularly every 2 weeks. The iOS teams were getting together for one full day, sometimes in the London HQ, some other times in the London team did travel to Bristol. This was really the key to unify the team, get the people talking. And next, we needed to get the support from the non-tech managers. So, because modularized code is easier to maintain and all that jazz we mentioned before, but sometimes it was not enough to convince product managers to sacrifice their backlog to have more modularization work to be done, since having a global platform was not something they really were interested in compared to achieving more short-term goals, such as maybe having a watch app or Apple Pay payments, or maybe food images populating the restaurant menu. So here's an argument to convince them. We can write the features only once rather than in 2 code bases. This way we go faster, and delivery managers in particular love to go fast. And as a consequence, one could ship the same feature everywhere and not only in one market. So if you are a product manager, you can show to the business how well your feature is performing and what a great impact your team is having in more than one country. Truth is, we rewrote the entire app over 4 years, going from a monolith in 2014 to a completely modularized code base in 2019, and a completely revamped product, as you can see. Because product and tech improvements should go reasonably hand in hand. Both parties should be understanding of each other. Another argument to have managers supporting the vision was that the current code was not in great shape to be iterated on, and sometimes rather than isolating existing code from one code base to onboard it in the other, was just easier to rewrite it from scratch. And doing the rewrite, we could take the opportunity to make the product more fresh, update the UI, possibly the UX, and tackle the known outstanding bugs. But let's finally start talking about these modules. This is how all of our code is organized from a bird's eye view. Since the goal was to share code that actually contains functionality, not just utility libraries, we did split the whole app into areas and domains. So the domain modules, the yellow ones in the pictures, contain the features for a given area. And you can do this split for any app. Looking at Just Eat, it's almost immediately clear what are the main parts, because the user journey starts with the home, proceeds to the list of restaurants, then the menu, the basket, the checkout, and eventually the order information screen. So domain modules never talk to each other. They don't depend on each other. They are completely isolated, really. And that's how it should be. You don't want symbols and classes to accidentally leak into places where they don't naturally belong to. So for instance, the concept of restaurant menu has nothing to do and shouldn't be visible to the module handling the order receipt for the Apple Pay payment information. Some other modules are in the core and shared sections at the bottom in the picture, and we're proud to say that a good number of them has been open source on GitHub. Both core and shared modules solve one specific problem. So from logging to experimentation and feature flagging to handling the navigation and the universal links. And by having all these building blocks ready, the apps could use them to create the whole experience. The ultimate goal we reached in 2020 was, of course, having one single code base for Just Eat, for the Just Eat app, having within itself the ability to switch country and reorganize itself accordingly, allowing the user to order food not only from the country they live in, but also from the country they maybe have temporarily moved to. With this design, the global app can scale horizontally, plugging in new modules, and new team can easily integrate new stuff. It also has the ability to scale by supporting multiple brands. We had 3 that evolve over time: Just Eat, Eat.ch, and Menulog. This is less relevant now that we unified the takeaway.com brand across all markets. But still, it's good to have an almost white label-like solution. And this was originally done with the intent of expanding Just Eat to more countries, potentially via new company acquisitions. All of this is powered by Cocoapods, and in fact, we have a stack using private pods and, of course, public pods for the components that we open sourced. All modules are created equal using the standard Cocoapods command that generates a project following a Cocopod template. They contain both business logic and UI, really everything that is needed to showcase the functionalities in a demo app. And we're going to talk about demo apps a bit more later. There is an underlying input-output approach to the surfaces here. I say modules accept services via dependency injection from the app, and in particular are configuration objects. These are the inputs, and expose a set of functionalities, the output. So for instance, the checkout module would accept a configuration based on the tenant and return a navigation controller to kick off the most appropriate checkout process for the given country. So if the tenant is UK, we might want to enable Apple Pay as a payment option in the configuration object. While if the tenant is something else, like Spain, for instance, we might want to tell the module to enable some other payment mechanism, PayPal, for example. Another example could be the location module, used to gather the user location and delivery address. In some countries, we want to configure the experience, allowing the user to enter a postcode. In the UK, for instance, this is perfectly fine, while in other countries where postcodes are not really useful to precisely identify a delivery area, Italy and Spain, for example, the UI to gather the address needs to be different, but still coming from the same domain module that reorganizes itself according to the specific need. And going back to a section from the previous slide, shared modules are a few in our case, and they have a problem. The problem is that they are indeed shared. And with that comes my first advice. So keep the number of shared dependencies low, and consequently, avoid the diamond-shaped dependency graph as much as you can, really. I often see this shape in articles discussing modularization. To me, this is a great example of where modularization is applied the wrong way. Because what's happening here in the picture is that we are just moving code around and creating a more complex dependency graph to compile and to deal with, causing the feature modules, the red boxes, to potentially not compile anymore if a major change is applied to the shared code. So sometimes it's not easy or even possible to avoid it. Just think about your UI kit wrapper you probably have, and that is used by all of your code. That's something hard to implement using dependency injection. Also, sometimes you're really better off by duplicating code. I can give you an example about addresses. We have at least 3 modules dealing with the concept of address. The address gather for the user location in the location module, the address of the restaurant in the restaurant module, and the address in the list of addresses for a user, yet another module. And yes, duplication sometimes is better. It might seem odd at first, but those address model structs are independently in principle. They have separate reason to change, and they are even owned by different teams. It's the app that is responsible for the flow of information and the orchestration of it all. In this case, for example, we could take the address the user has entered in the beginning of the journey and have the app to convert it to the shape of another address, the one expected from another module later in the user journey. And think about your UI kit wrapper or any other low-level framework you have implemented. Foundation components should change rarely, but your code changes quickly by nature. You can think of Apple's foundation and UI kit as shared components that all of your code depends on. They usually change once a year, and engineers at Apple make efforts to keep things backwards compatible as much as they can. At least for your code, you don't want to deal with backwards compatibility. That's unnecessary effort. You just want to move forward and fast. After all, if you're building an app, this shared code is used by your team only, unless, of course, you're building an SDK for your clients, but that's a bit of a different story. And in that case, you might want to put efforts in keeping things backwards compatible. Moving on, another advice is to make your dependency tree as flat and spread out as possible, because guess what? Compilation times get better because Xcode can compile units concurrently rather than having to wait for a framework to be built before proceeding with the others. You see how this is a lifesaver compared to having a monolith. I still remember when the Just Eat app was building in 8 to 10 minutes years ago. Lots of coffee breaks at that time. Of course, now we have faster computers, but we also have much more code to deal with. And the whole app now builds in around half of the time, around 4 minutes. Clearly, this is easier said than done. This is the dependency graph for the SERP module. SERP stands for Search Engine Results Page. In other words, it's the list of restaurants. And as you can see, there are already 3 levels of dependencies, some internal and some external. And of course, as a general rule of thumb, you should always try to keep the number of open source components that you use to the minimum, so that when the next iOS version comes out, you don't have to cross your fingers in the hope that the authors of these dependencies still support the libraries and have applied the necessary changes for the new iOS version. Which brings me to my next advice. Think open source. When you use an open source component, you usually take a look at the README file for the initial documentation, make sure it's solid with a good overall shape and has some decent tests. These are the most important things. If you are not satisfied with either of those, you will not be that keen to using it. So why treating your code differently? Eventually, someone else in the team will use your components. So make your module brilliant like you would do if you were to open source it. Write a README file, make it easy to integrate, write some good amount of tests, and make sure it has reasonably shaped code, because you don't pick third-party software because of the architecture, but because of what they can do. I want developers to be able to get a grasp, not to understand the whole code and architecture behind the module immediately, but just to be able to get a grasp of a module in less than 10 minutes. It's about the first impression, really, and from there, they can dive deep as much as they want, if they want to learn more, and if they need to. Following up on this, don't be fussy about a specific architecture. It's simply inevitable that some developers prefer some kind of architectures, while others prefer others. I'm talking, of course, about reasonable and well-known architectures such as MVC, MVVM, Viper, this kind of stuff. Also, some team leaders invest time in having the whole team buying into a specific architecture because maybe they really believe is the best one solving all the problems. And spoiler alert, this is false. There is not a single architecture that fits all sizes. And just the fact that there are so many articles online discussing them is the evidence to me. And maybe sometimes these team leaders succeed. They convince the team to adopt a single architecture everywhere until a new developer joins the team and starts questioning the original agreement. The reality is that you could spend that time better. Don't pick up a battle. It's not worth fighting, and that brings no clear advantage to anybody. We're all much more productive if we use what's already in our toolbox. Enforcing a single architecture is a big bet if you think about it, and would ultimately cause some discontent and some developer down the road going vocal with, if only we had used Viper instead of MVC, now we could introduce this new feature in a breeze. After all, when scaling software, the architecture used internally to the modules becomes less and less significant compared to the bigger architecture orchestrating the various parts. This concept comes from the microservice architecture used for orchestrating the backend services. All the modules that you've seen in the previous slides have different architectures. Some played out well, some others not so, but we can certainly say that we've learned from the different styles, and in hindsight, we can say what has worked well and what not so much. So stick to more general principles. Evangelize solid principles, for example. Focus on having the code maintainable and readable and reasonably documented, more than being too focused on having that particular view model class written by the book. The next advice from me is to think simple. If you force yourself to think simple, the code you produce will ultimately reflect that. This is particularly important if you adopt the facade pattern. A facade is an object that serves as a front-facing interface, masking more complex underlying code. Imagine a module having a tiny surface as integration point, a facade object that exposes only the functionalities that are meant to be public. The smaller it is, the easier the integration becomes. Facades also help you to deal with Swift and Objective-C interoperability in case you still have some legacy Objective-C code hanging around. Let me give you a bit of an extreme example here, but let's say that a module is completely in Objective-C, but the consumer is in Swift. The facade of the module could well be some Swift code that completely hides any evidence of Objective-C. Or if instead the client is in Objective-C and you are working on a new module in Swift, we can mark only the relevant symbols in the facade with @objc and @objc members. Facades help you to reduce the scope of things that you need to expose as public for real. Also, modules will eventually evolve and grow in size. Think about the following statement. A component interface should increase slower than its surface area. This both applies to in the small to classes and in the big to the modules. You know that classes should be open to extension. Let's say that we had a few new methods to a class. It's reasonable to think that the interface will slightly increase, or maybe not, because what we have added was just hidden implementation. Same goes for the modules. Adding a new functionality may be completely opaque because it's all internal to the module, or it can be exposed by the facade interface, which should just grow a tiny bit, not adding too much in terms of integration effort. Ideally, the interface of the facades is showcased in the demo apps, and really invest in the demo apps. It was a lifesaver for us. Still, not many companies do this. Following up on the think open source advice, some open source projects, especially the visual ones, come along with a demo app. This is the easiest way to see what a module has to offer. In the screenshots there, you see the account module. The section at the top is pretty much a one-to-one match with the facade methods. Having a separate environment also allows you to extend it as you please. And what we often do is adding the ability to mock the services that are injected into the module so that we can test a variety of error cases. This also enables saving continuous integration time by running UI tests within modules and leaving much less to test in the final app, where we usually have a limited set of end-to-end UI tests. And also, demo apps are a great selling point for product managers, especially with companies having adopted over time similar models for structuring engineering teams, such as the Spotify model. Developers in the different squads, or whatever else the buzzword is to refer to a functional team, they would ultimately work on a subset of the product. So if you want to make your product managers happy, tell them that they can check the progress of the features every day in the demo apps that CI builds overnight without having to wait for the final integration to happen. This enables faster feedback and more peace of mind within the team in general. That's also why splitting the app by domains or areas is reasonable, because it aligns with the structure of the tech department and its various feature or functional teams that are actually responsible for only some parts of the app. The first module that we implemented was a proof of concept. We started small, taking one tiny part of the app and turn it into a module. This showed other teams how this process works and allowed them to start adopting the same approach, enabling ownership, so having teams owning some specific areas of the app. Also, if you look at how your company is evolving, teams get created and rearranged all the time. Taking that into account will allow you to organize any refactoring more sensibly, reducing any code freeze time so that teams can progress with their features without being blocked. I'll also briefly talk about another hot topic in the community, the usage of a monorepo, a single repository hosting all the code. This is much known in big tech giants such as Google and Facebook. At Just Eat, we used to have modules in different repositories for iOS, and we've recently moved towards this approach that gave us huge benefits, and I cannot recommend it enough. First of all, this allows to keep the versioning of the modules in sync with the app, so that when it comes to, for instance, applying a hotfix in a release branch, we can immediately change what's needed in the module, opposite to create a spurious version of the modules that may already have progressed with other changes that we're not really ready to bring in the current release. Also, not having to publish pod specs anymore is really a blessing, and nobody wants to go back to how things were before. It reduces the cognitive load, and it avoids interrupting the work between implementation in the modules and integration in the app. Also, merging all code into a single repository has an impact on our continuous integration pipelines, actually a positive one. We could simplify the setup of the CI, running all we need in one single go without having to run first the unit test or an UI test per the module on CI, and only later run the test on the app. And quoting Peter Steinberger, we had to smartly construct our pipeline to run only the stages that are relevant. So for instance, if a pull request only changes module A and B, there's no really point in running the test for module C and the others. This is something you have to do yourself. There are no out-of-the-box solutions out there, as far as I know. In our case, this is done with a tiny Groovy script in the Jenkins multi-branch pipeline that looks for the changes in specific paths of the monorepo, comparing the pull request with the main branch. It's fair to say that the average pull request only changes something in one module and in the app for the integration part. So we don't execute too much stuff for every pull request, only what's necessary. Modules are still isolated, maintaining the same structures with the demo apps. Basically, what were private pods before are now treated as development pods, subject to the versioning of the monorepo. And circling back to the shared components, here's another limitation about them. Second-level dependencies. cannot be treated as development pods in the pod spec of the first level dependencies. This is simply not allowed by Cocoapods. You cannot have a published pod spec referencing a development pod on disk. So they have to be maintained as separate entities with their continuous integration pipelines still publishing pod specs for new versions, which again is another reason to avoid shared code as much as possible. So these are some advice I thought of sharing with you today. Clearly there are more. I hope you like the journey you heard of going from 2 separate and different products and code bases to a single one. If you're working in a startup, hopefully you will have now clear ideas on how to adjust a fairly young project so that you won't regret in the future the decisions that you make today, because it might very well be that in X number of years, you will still be working there and you don't want to deal with unmanageable complexity. So invest in the future. And if instead you're working in a more structured environment and you already have the feeling that things could be made a bit more modular, hopefully you got some inspiration, you know what to keep a lookout for and how to gradually introduce modules, maybe starting small and get the support of your team. There's an article on my blog and the Just Eat blog about the journey with some more technical details. We also write about iOS things in general, and I encourage you to take a look at those articles. So go check it out and reach out if you are interested in discussing more in depth. You want to know more about how we do things at Just Eat Takeaway, or in general, if you want to share your experience with modularization, I'd be very interested in hearing from you. Thank you. And now I will load the questions. So the first question I see is, hi Alberto, really great talk. If it is public, what is the build time of the app? Did you consider creating frameworks for the modules? So yeah, it is public. I can talk about it. The build time on my machine, and actually also on the Mac Minis that we use for the CI, is around 4 minutes, 5 tops, really. And so yeah, that was a great improvement, because just 3 years ago, when everything was pretty much a big monolith, I remember it was 10 minutes. Clearly, as I said, it was also with older hardware, but there is definitely an improvement there, and you can see Xcode building in parallel the modules. And did you consider creating frameworks for the modules? So these pods are generated by Cocoapods with frameworks. So yeah, they are frameworks. And a similar question I usually hear get asked is if we, instead of frameworks, we use static libraries. So there are different approaches here, right? We decide to go for frameworks because, with dynamic frameworks, because otherwise, if we get a crash in production, with a static library, you really don't see the stack trace enough. But I know other companies do it differently. Spotify, if I'm not mistaken, they build everything with static libraries because they are confident that they're not going to ship any crash. Or Facebook probably does something similar. I cannot speak for that. So yeah, we go for frameworks generated by Cocoapods, and I guess that in the coming months and years there will be a trend moving towards Swift Package Manager. Another question is, how do you determine when code should be packaged in a module? So what we've done so far is we try to understand if an area, visual area, could be owned by a specific team. So one of the most recent teams that got created is the offers team. Also, well, I have other examples as well, but the offers team. So you know that there is a tab in the Just Eat app that is about offers. So everything that is within there belongs to one team, and it instinctively it will say, I will say, is something that you identify as something that should live separately in its own space. And that's for domain modules, right? But also for the low-level modules, they solve specific problems. So for logging, we have one specific module that just does that. It does logging on Kibana and our ELK stack, and solve that specific problem. So the moment that you see that there's another problem to solve that really doesn't fit instinctively into the scope, in the scope that you already tackle, it means to me that it has to be solved somewhere else. So we make a module for it. And as I say, some of them are open source, so please go check it out. Particularly proud of the navigation engine module that really includes everything around navigation. That was a bit tricky because it spans across different modules, right? It should span across different modules. And so everything around navigation and universal links is within there. And another, Sebastian says, using Swift Package Manager makes life so much easier. Yeah, as I say, there will be a trend soon where all the components are on Swift Package Manager, and we can make this transition smoothly. Franklin is asking, so what architecture is used at Just Eat? Well, we have this modular architecture with the module independently. So I guess you're interested in the architecture at the top level, so how the app organizes, orchestrates all the things. So it's not much of a secret, right? So the things that the app has to do is to implement the services that are required by the module. So for instance, if the orders modules needs to make some API calls, loading the order history or loading the order details, something that we want to inject is an API client, which actually comes from another module that solves just that, the network layer stuff. So we create all the services that are needed, sometimes in a lazily loaded way so that we don't load up too much stuff at startup. And that's for the part of services. And then there is the part of UI that grabs the necessary view controllers from the modules, put them in the tab bar, and creates the UI. All of this is done with operations queues in a top-level object, pretty much close to the app delegate, right? So there is one operation queue that runs on the main queue. There is another operation queue for background task. And we put stuff in there for, when on cold start and warm start. And that's pretty much how things are created. And then is as I said at the beginning, it's just about implementing the services and the objects that are needed to inject into the modules. Another question from Daniele. Hi, Alberto, thank you for your great talk. As usual, we started a similar path following your suggestion. However, actually, I limited the number of modules. So I have a question for you. What's the process you follow to decide if a particular flow must be part of a separate module? Say that's pretty similar to the previous question. When you reach the point that you know that something doesn't belong there, doesn't belong to the problem that you're solving, that is a sign that you have to solve it in a different area, in a different part. So it's more about being a bit pragmatic and think of how you will naturally split some areas. When an example here, there is the restaurant module that is about the restaurant page, right? The menu, and also the basket. It has a lot in there. We originally thought of splitting the restaurant module in two things, the menu module and the basket module. But then we realized that actually the basket and the menu are so entangled that it's probably fine. We can put all the things in one module there, right? So if things get too entangled and there's a reason for it, there's a legit reason, maybe you can put everything in one module. Guess I can pick another question. So Davide is asking, which platform and tools do you use for continuous integration, and which jobs stages goes under the CI pipeline for a module for the app? So we used to use Bitrise on the cloud. Over 2 years ago, we moved to in-house stuff. So we use Jenkins. We have 8 to 10 agents, and now we're working from home. So they are all at our homes. They are Mac Minis. And the jobs that we run there for the modules, usually the template is, well, reset the state anyway, then run the unit test, run the UI test, if there is UI in the module. So this is the case for all the domain modules. For more low-level stuff, maybe there are no UI tests. Then we progress with gathering the code coverage using SonarQube, using a local script for SonarQube, and then the next stage is to submit the code coverage to SonarQube so that at pull request time, we know if a pull request can be merged because the code coverage hasn't changed or has increased, but if it went down, we stop it there. And for the app, we do exactly the same thing. So we run the unit test, we run the UI test, and actually we have, we use test plans, and we divided the UI test in different test plans, trying to organize them in a way that actually makes a bit of sense. And then we proceed with getting the code coverage and submitting the code coverage. So the single pipeline that runs all of these is has the declarative syntax pipeline, I think it's called that way, that understands what are the things that change in the modules/path. And if something has changed in /modules/account, we know that we want to run the unit test and UI test and the code coverage for the account module because something has changed there, while it ignores everything else. I guess I'm at the end of the 10 minutes. So I will stop right here.
Hi, Alberto. You can have 1 or 2 more questions if you want.
Okay. Go back there. So another question from Amin is, let me mute because I don't hear myself. How does these demo apps work? How will they get their feeds? So they work in the sense that they have to showcase really what the module has to offer, right? So again, with the example of the account module, the account modules allows you to log in, to create an account, to reset your password, and a few other things. So they get fed with mocks, really. So actually, some of them have the option to just use mocks, some others to actually hit the real API. So if you hit the real API, you know that things can be up or down depending on the environment. But if we use the mocks and you enable within the demo apps to use the mocks, you can create all the code that you want to inject a mock that is faking the logging to fail, or that is faking the logging to succeed, or anything around this. Or you can even fake particular error messages to be show up because maybe username is already existing, so you cannot create an account, or things like this. So this is all done within the demo lab. And this code, yes, it is extra code, so you have to put extra effort in maintaining this. But in the long run, the gain that you get is so high that is worth doing, definitely. It also makes things much more easier to debug, really. So, for instance, if some users experience one particular problem and they start reporting that they see a specific error code, like 1100, we can check in the code what is that error message, and if there are tests, we know what it is, and they immediately tell us what it is, and they actually provide some documentation for it, actually test our documentation for it. And if they're not, well, that's an opportunity to expand the test for it, so to also increase the code coverage. Last question, okay, what was the decision process and reasoning for your team to move from Bitrise to Jenkins. So Bitrise was a really good platform. There is even on their website a user case story with us. So if you search Bitrise Just Eat, you will probably still find it. The issue we had with it was that they, at that time at least, they couldn't give a on-premise solution, and the company decided that all of our code has to stay within our network, within our VPN, and so they didn't want us to host the code on github.com because that's what we were doing, right? So we had to move the code internally, and Bitrise was not, couldn't do that thing. It was not on-premise. We decided to go for Jenkins because Jenkins is really a great tool. Some people don't like it, or maybe they say it's too complex or it's not that it has a clunky UI, but it is very powerful. It allows you to do so many things. So it seemed the best thing to adopt. Otherwise, I would suggest other CI solutions on the cloud, like Circle CI. That seems very, very cool, very well done, and easy to integrate. I guess that's it. I'm going back to...
Thank you, Alberto. Thank you very much for this wonderful talk, and see you on Umbrella or one-to-one meeting. Thank you.
Alberto.
Thank you.